So today what I would like to show you, I'd like to start out our lecture with a trick for memorizing polyatomic ions. So yesterday you guys were learning about how to use polyatomic ions in formulas and names. But now I want to show you a trick for memorizing because you have your flashcards done and it's kind of tricky to memorize those. On your notes, if you don't have about, 5 or 6 inches of room, go ahead and start on a fresh page. So if you're at the very bottom, you probably want to flip over to the next page. All right. Are you ready? I want you to write Nick, the camel. Nick the camel ate clam for supper in Phoenix. Yes, write this down. Nick the camel
are vegetarian.
Nick the camel ate clam for supper in Phoenix. Yes, I know it doesn't really make sense that there are camels in Phoenix. And why would you only eat one clam? I mean, you eat clams usually, but
Camels are vegetarian.
And camels are vegetarian. So this doesn't make sense. Besides, who names their camel Nick?
You forgot Niall. The dot. The dot and I.
Oh, okay. So Nick the camel ate clam for supper in Phoenix. Now, yesterday, did you guys notice, and if today you don't mind looking at your polyatomic chart, do you all notice, gentlemen, can I have your attention back there? That way you're focused and engaged. Do you all notice that many of the names end in 8? They end in 8. Look, I'm putting a box around this. This mnemonic is a way to help you memorize the 8s. So Nick stands for nitrate. What do you think camel stands for? Carbonate. Yeah, good. What do you think clam stands for? Chlorate. Good. What do you think supper stands for? Sulfate. And good, Phoenix stands for phosphate. Please raise your hand when you've noticed the pattern. I would like you to look at nitrate, carbonate, chlorate, sulfate, and phosphate. Please look at the formulas. Please look at the chemical formulas on your chart and raise your hand when you notice a pattern. Sabrina has noticed a pattern. So I'm asking you to look at the formulas. Well, yes, the name, they're all ending in ATE. Good. Now look at the formulas. More than one of you need to notice a pattern because I'm asking you to look at things. What pattern do you notice? Good. Emily notices a pattern. No, not the name. I know the name. The name we notice that they all end in 8. Look at the formulas. What do you notice about all of the formulas for nitrate, carbonate, sulfate? Okay, Ryson notices a pattern. Damien, are you noticing a pattern? No. Okay. Emily, will you tell me one pattern that you noticed?
The number of vowels is the charge.
No. I mean with the formulas.
Oh, you mean sorry. I was saying what it.
Yep. You're ahead of me. What do you notice about the formula, though? Sabrina?
They all have oxygen in them.
They all have oxygen in them. How many of you guys now notice that pattern? Bryson, did you notice a different pattern?
They all have negative charges.
And good. That's the other obvious one. They all have negative charges. The obvious is they all have oxygen. They all have some type of negative charge. Now, what Emily was talking about, I'm about to show you. So first of all, let's do this. We know that there is an N and an O, some amount, some charge. We know they're all negative. We know carbonate is a C and some amount of oxygen. Chlorate is a Cl with some amount of oxygen. Sulfate is a SO, some amount of oxygen. And phosphate is PO and some amount of oxygen. Did you have a question?
Yeah, there's positive one. They're all negative.
Yes. So on a side note, one of the things, another pattern, if you're noticing, do you guys notice almost all the polyatomic ions except one are negative? So what Ryson showed us is all of these 5 are negative, but to be honest, all of them are negative except ammonium. So if ever you're wondering, is this a positive or negative charge? Bet that it's probably negative. All right. So, you guys remember consonants and vowels? Okay. Ryan, you have a question? Why is one what? Permanganate, yeah. Because it didn't fit. Yeah, so I'm giving you a mnemonic to remember these 5, but not all of them. So manganate or permanganate, you'll just have to memorize. Is that one of the ones I asked you to memorize? I can't remember. Is it? Yeah. So unfortunately, this isn't going to help you with that memory, but at least it'll help you with these 5. All right. Consonants and vowels. Nick, how many consonants are in Nick? There are 1, 2, 3. How many oxygens are in nitrate? 3. Oh, that's cool. What is the charge on nitrate? Negative. How many vowels are in Nick? 1.
Whoa.
Whoa. Isn't it?
What?
Camel. How many consonants are in camel?
2.
1, 2, 3. Guess how many oxygens there are in carbonate? 3. All right, how many vowels are in camel? 1, 2. Guess what the charge is for camel? Negative 2. Isn't that cool? Nice, easy way to memorize. All right, clam. How many consonants? 1, 2, 3. How many vowels? Just 1, so it's minus. Okay, sulfate for supper. We got 1, 2, 3, 4. There are 4 oxygens. And then, yep, 2. We got 2 vowels here, so the charge is negative 2. And then phoenix, 1, 2, 3, 4. And hopefully you know how to spell phoenix. It is a bit tricky. You've got 1, 2, 3 vowels, so it is a negative 3 charge. Great, huh? Isn't that nice? I spent 25 years doing chemistry, and remember how I told you guys I went back to college and took a chem class for fun, because that's a fun activity for me. My professor showed me this, and I was like, wow, so nice. Now it gets even better. Go ahead and look at your polyatomic ion sheet. What pattern do you notice about 8 and 8? So I want you to look at like sulfate versus sulfite. Look at phosphate versus phosphite. Raise your hand once you realize the pattern. Emily has seen the pattern. Ryan, seen the pattern? I'll repeat myself. I want you to compare the 8 to the 8. So nitrate versus nitrite, or carbonate versus carbonite. Bryson sees it. Sabrina sees it. Ryan? Ryan, what pattern do you notice about the ite? One less oxygen. Perfect. One less oxygen. Emily and Ryson and Sabrina, is that what you also noticed? Okay. Those of you who didn't raise your hand, do you now see, when you look at the 8 versus ite, do you guys see how it's one less oxygen? So, I'll write in blue because they're so loud in the hallway. So here, nitrite is just one less oxygen. Notice the charge is the same. Carbonite, I don't even think that's one. Is carbonite even on there? No, but look, here it is. Chlorite, just one less oxygen. Then sulfite, one less oxygen. Again, the charge doesn't change. And then finally phosphite. PO3, 3 minus. So Nick the Camoate, Clam for Separ, and Phoenix, all of a sudden you now can memorize 10 of those polyatomic ions just from that. So you could figure out what the 8 is, and then from there go one less oxygen to figure out what the ite is. Now, chlorate is a special family. Do you guys see on there how there's perchlorate and hypochlorite? Do you see that? First of all, I would like to remind you what the prefix per and hypo mean. Per, it's like hyper. Hyper meaning lots. Woo, yay, lots of stuff. Hyper means, guess what? One more oxygen. So if you put a per in front of chlorate, so if you put a per, I'm just going to put a per in front of chlorate in a different color. If you're just using pencil, maybe you should write out perchlorate. Guess what? It's just one more oxygen, ClO4 minus, compared to its chlorate partner. And then hypo, the prefix hypo, you guys have heard hypo, like hypothermia, that means your body temperature is less than. A hypoallergenic pillow, maybe, means that it doesn't have allergens. Hypodermic needle means it doesn't have any germs on the needle. Hypo, less than. So if you put, I'll do it in purple, if you put hypo in front of chlorite, then you take the chlorite and you do even one less oxygen, so it would just be ClO minus. So cool. Clam can tell you what a chlorate is, and from there you can deduce or figure out what chlorite is, hypochlorite, and then also perchlorate. So all of a sudden you got 4 polyatomic ions that you can have memorized. Chlorine, see where it is on the periodic table? It's the second to last column. What family do we call that? Halogen. Yeah, it's in the halogen family. So halogens have a unique characteristic. Chlorate isn't the only halogen that bonds with oxygen to make a polyatomic ion. Do you guys see some other halogens on your paper bonded? Is bromate on there? Or iodate? Iodate is on there. So guess what? All the halogens, with an O3 minus are all called halogenate, like halogen root plus that 8 ending. So what do I mean by that? I mean that you could have fluorate. You can have bromate. You can have iodate. And guess what their formula is? It's identical to chlorate. How do you remember what chlorate is? From clam. So if you could figure out what chlorate is, then automatically you know what fluorate is. It's FO3 minus. You know what bromate is. It's BRO3 minus. Or iodate is IO3 minus. They're all the same. You know what else is the same? If you did you could do fluorite, bromite, iodite, and you know what the ite means. Ite means one less oxygen, so it's the same formula. Two minus. And then again, I'm not going to do all of it, but if you put hypo in front of it, hypofluorite, let's say. Geez, I can't spell. That would just be one less than its ite partner, so just be FO minus. And then, of course, if you do per in front of your fluorate, you have one more oxygen. So do you see this pattern? It's O4, O3, O2, O1, I guess. They're all negatively charged. And it's just some halogen with oxygens, and you get to plug in whatever halogen you want. And that would be the same for bromate and iodate. So you could have hypobromite and perbromate, same thing. Pretty cool, nice way to memorize. When you get to a test, not the final exam, I'm not going to have you do this from memory on the final yet. I will do some memorization tests though next semester. I'll give you a few, like here, memorize as many as you can do, and I'll give you multiple opportunities because memorization for some is quick and for others takes more practice. So I would like to honor whoever you are and give you as many quizzes as you need so you can master this memorization. And this trick is really helpful when taking an exam. In fact, what I did when I was taking my exams, I would get my test, I'd literally just write on it, Nick the camel ate clam for supper in Phoenix. And I'd just throw that on the paper right then and there. That way, if I needed to access it and I was kind of stressed out, I didn't have to forget Nick the camel ate clam for supper in Phoenix. All right? So there's my trick. Now, today, there is one more thing we need to talk about with respect to ionic bonds. So far, ionic bonds have been between two elements, or they've included polyatomic ions, and I have asked you so far to ignore the transition metals. Well, we can't ignore them forever, so let's learn about ionic bonds with transition metals. Ionic bonds involving transition metals. Go ahead and sketch yourself just a little rough periodic table. Where are the transition metals located? It's this section in red right here. So that's what we identify as transition metals. A couple things about them. Transition metals, when charged, are always cations. What's a cation? Something that is positive.
What charge do they normally all have? Like on bases, like is it like 1s2 or is it like s2 or s1?
That's my next part. What does charged mean though? Remember, charged means the protons do not equal the electrons. So in this case, transition metals will always be giving away electrons, because when you give away electrons, you become positive. Now, there is no trend by columns. And what do I mean by that? You know how this first column is always plus 1? You know how the second column is always plus 2? Column 13 over here is always plus 3. You can always count on that to be true. Well, transition metals, this is what you were asking, I think, Sabrina. Transition metals, there is no trend by column. It's not like, this column's always plus 1 and this is plus 2 and so on and so forth. There is no trend. And in fact, some metals take on multiple forms. So an example of that would be like iron 2, which is Fe2+, when it gives away 2 electrons. And then iron also can take on the form iron 3, which is iron 3+. So iron does that, copper does that, other metals do that. Some, like silver, only takes on one form. It's always plus 1. Zinc, it's always plus 2. It really just depends. I asked you to make 7 flashcards for some common ones I'm going to have you memorize. But all of those transition metals can take on some positive charge and sometimes multiple positive charges. So the rule for naming, with transition metals is really similar to what we already know. You take the cation, you take the cation name, you put a Roman numeral representing the original charge. So you have to put a Roman numeral after it. And then, of course, you just put the anion root plus the ending "ide." Same as before, like chloride or carbide, nitride. Or if it's a polyatomic ion, you just use the polyatomic ion name. So carbonate, sulfate, perchlorate, whatever it is. First period, I learned that a student learned her Roman numerals when she was in 4th grade. Maybe that's you, or maybe you actually just never really learned your Roman numerals. Because Roman numerals, I think the only place that I know that they're used is in games, music, and Super Bowls. So we don't... Star Wars? You're right, Star Wars. Star Wars uses Roman numerals to represent which episode? Ah, there's a better one. I like that, Star Wars. All right, so in case your 4th grade self has forgotten Roman numerals or you just never learned these, I'd like to do a quick review of Roman numerals. Number 1 is represented by just I. 2 is I. 3 is I. And mine.
Fine. Fine.
4 is a little different. It is IV, and that is because 5 is represented by V. And then you start to go after the V. So this is VI. 7 would be VII. 8 is 5 plus 3, good. VIII. And then what you do for 9, here I'm going to jump to 10. 10 is X, so 9 is 1 before 10, so you do IX. And then, like 11 would be XI, and so on and so forth. Now,
Wait, what's 20?
20 is, what do you think? If 10 is X, yep, 20 is XX. Guess what 30 is?
3x.
XXX. Okay, but what is 40? Because 4 does 1 before 5, so we need to know what 50 is. So 50
This is easy.
is L.
It's XM.
So it'd be XL is 40. And what would 60 be? It would be LX. All right, so 50 is L. 100 is C. Yeah, like century. Yeah. And then 500, because, like, what would 200 be? It'd be CC. What would 300 be? CCC. But then you get to 400 and 500, so 500 is D. And then 1,000, my Spanish speakers in the room, what is 1,000 in Spanish? Mil. Yeah, so M.
No.
A lot of these are Latin based, and Spanish is Latin based. So science, often for my Spanish speakers, your brain's programmed already, which is kind of nice. I don't know Spanish, so it sucks for me. Not yet. I will. All right. We could probably keep on going and going and going for Roman numerals. For chemistry, though, chemistry purposes, let's take a step back. Why did we just refresh or relearn or learn for the first time? It's because we have to put the Roman numeral after the transition metal to represent its original charge. Now, in chemistry, you're going to use II, right, for 2, probably III for 3, and IV for 4. Most transition metals have a charge of 1, 2, 3, or 4, and not much higher than that. There are some occasions that you'll have 5, 6, 7, or 8, but in this chemistry class, you won't. Now, how many of you guys are thinking of medical industry careers? Yeah? So if you're thinking of medical industry careers, especially my nurses, I assume my doctors in the room would probably have to take a similar class, but one of the classes that you take is nomenclature for chemistry, and the reason is nurses, well, doctors are the ones that prescribe drugs. Nurses are the ones that administer drugs when they're in hospitals. So it's really important for you to understand the chemical that you're putting into your patient, and many of the chemicals are named with these chemistry terms. The medical industry, however, uses the old school naming, the old method of naming. And the old method of naming, so you know how we have, sorry, it keeps expanding here. We've got iron 2, and we have iron 3. So in the old school method of naming, this is called ferrous, and this is called ferric. If ever you were wondering why the symbol for iron is Fe, because you're like, how does the F and the E have anything to do with the spelling of IRON? It's because its original name is fair something, fair, I don't know. So the charge is ferric or ferrous. Copper is another one. So you've got copper that takes on a charge of 1, or copper could also take on a charge of 2. This is cuprous, and this is cupric. So ick, yeah. Yes, you can. So just so you know, ick is the higher
We need to write this.
charge. Yes, you do, because you're going to see it as copper 2 and you'll see it as cupric. You'll see it both ways. So ick is the higher charge compared to us, O-U-S. So ick and S are endings that represent the charge. So if you're doing the old school naming, you don't do Roman numeral. If you do the new form of naming, you use the Roman numeral after the cation name. I would like to show you examples of what I mean now, and then we'll be done with our lecture. Can you guys remind me what time we get out of here? Is it 12?
53.
Okay, I gotta hurry. Really hurry. I'm gonna ask if you have your flashcards. I need you to, it's gonna be really fast for me to grade, but I might need to have you wait after lunch to show me because I'm gonna run out of time. I'm gonna hurry though. So, real quick, examples. We could have iron 2 oxide, also known as ferrous oxide, or we could have iron 3 oxide, also known as ferric oxide. So what is the formula for these? So what you have to do is iron, what's the symbol? Fe. What's the charge? Well, you look at the Roman numeral. It is a, 2 plus. How do I know that? Because the Roman numeral. Oxide, what is that? Oxide. Oxygen, good. And the charge for oxygen is -2. So what's the formula for iron 2 oxide or ferrous oxide? It's just FeO. But if you have iron 3 oxide, it's a +3 charge with oxygen being -2. So now you do that trick of swap and drop. You need 2 irons for every 3 oxygens. And if you notice, 2 very different formulas, yet the name is still iron oxide, but the Roman numeral indicates which one it is. Okay? So that is how we do transition metals. I would like to acknowledge the fact that you might feel like right now you're in a Spanish class or Japanese class or like a foreign language class, and recognize foreign language takes a long time to learn. This you're not going to learn instantly, and it's going to take a lot of practice, of which we are going to do a lot of practice after final exams. Okay?